Hey everyone. Today we're going to jump into, as you can see the title up at the top there, we're going to be creating equations of parabolas. So this is a pretty quick lesson for us to go through, and it's really kind of a culminating task in a way. We're going to take what we've dealt with our parabolas, and we're just going to kind of move it into a different area. Can we go backwards? If I was given a list of properties, or if I was given a picture like you see on the page, could we create an equation that would represent that? So I want to jump right in right away and just acknowledge that there is nothing in the problem that asks you what form to put that equation in. And so for us, we have a number of different forms that we can deal with that. We could address our good old vertex form, which is one we should be very comfortable in dealing with. We could also address a standard form, and I would be very careful to always look at the wording of a problem. Notice that if it does say in standard form, then we're going to have to expand any brackets, collect like terms potentially, if we don't choose that method to begin with. And lastly, I want to remind ourselves, and who really cares about what variables are in these places, but we do also have that factored form version of a quadratic equation as well. So those three could all be starting off points for us. So let's take a look at the picture that we've been given, and we're going to have to go through and determine the equation of that. Now, what I'm going to do, before we just jump into the problem, is I want to look at the picture, and I almost don't even want to deal with the specific instruction to the problem. I'm going to just look at that parabola, and I'm going to label as much stuff as I can that I see on that parabola. This is not how I would necessarily begin the problem, so I need to be very clear on that. But for us to be able to try to map a pathway through, we might notice that the forms of those equations that we've given in blue, red, and green might be more or less useful depending on the information in the parabola or in the problem. So the first thing I notice is I can see that I have a vertex. And I can tell what the coordinates of that vertex are because I can read the coordinates off the grid. My x-coordinate is going to be at a -3, and if I go up my units, my y-coordinate is going to be at 5. So I want you to notice that by having the vertex, that might lead me towards using that blue. Okay, the next thing that I would consider is any other special points, and I do notice that down here, I don't have exact x-intercepts. Like what I mean by that is I'm not crossing through the exact intersection of grid lines. Yeah, I could estimate that first one would have to be like -1 point something, and the other one would have to be at like -4 point something. But those aren't going to help me at all because they're not perfect. They're not exact. Okay. Well, that's the only information that I can kind of see in terms of special properties. I can't see a y-intercept on that graph. Okay, so let's take a look and see then that the only piece of information that was given to me was the vertex. That is going to lead me to want to use vertex form. Okay, so now I'm going to jump in and I'm going to work with our problem. So what I'm going to do is just put a little wavy line down here. And what I may begin with is my vertex form. Because at the very least, what I know now, because of the coordinates of that vertex, I know that my vertex is at -3 and 5. Recall, my vertex is always in the coordinates HK. So what I could then do, and I want this to be in purple, is I know that the equation of my parabola has to at least start off that way. Okay, well, I don't have a complete equation of my parabola because I still have this a value out in front, and I haven't solved for that a value. However, when I look back at my parabola, I do notice that I have some other things on there that will dictate my shape. So if I scan down my parabola and I look for, are there any other exact points that my parabola goes through, I can find a number of those exact points. Those I am very confident that my parabola goes through. So I'm going to just label on the coordinates of those points. -2, 3, -4, 3. That would be like -1.5 and 0.25. Nope, because that scale is 1. How about 0.5? And the matching point on the other side is going to be at a -4.5 and up a half. So I get all of those points on there. Okay, well, I could use any one of those points to help dictate my shape. So what I'm going to do is just shrink down this picture a little bit. And I'm going to pick the one that I think is easiest to work with. I'm going to sub in the point -2, 3. That has the smallest coordinates. I should be good. Recall what that says. That says that if x is -2, then y must be 3. And so I can sub that point in. Okay, well then that means replace my y with 3 as long as I replace my x with -2. And you'll notice what you create. You create an equation that just has an a in it. We can solve for that. Okay, maybe I just expand those brackets. That's a 1 squared, which is just 1. Now I can get rid of the 5, and I get an a value of -2. I'd also like us to know we got a little confirmation. My parabola is opening down, and I got a -a value. So I feel pretty confident with it. That would lead me to then be able to state an a value of -2 with that vertex is my parabola. Now, I do want you to notice that I'm not 100% confident in that. Like, I was trusting my eyes that it went through that point. So I could pick another point on my parabola to check in that equation to ensure that I was correct. Be very careful. Don't pick the point across from it. What you're going to get is just confirmation. Keep in mind that those 2 points, the points that are directly across from each other, are mirror images in the axis of symmetry. So, as soon as I forced my parabola to go through the point -2, 3, well, then I also forced it to go through -4, 3. However, this point down at the bottom, I trusted my eyes independently from the point that I subbed in. That would be a good check point. Do a little left side, right side. Replace your x with -1.5. Replace your y with a half. And you work your way through, and we'll get a little confirmation that we're correct, and therefore we have a lot of confidence in our equation. Okay, now as you work through that, one big question may have popped into your head. That did you have to use vertex form? And I can tell you, no, you didn't need to use vertex form. But I do want to walk you through maybe a little bit where those other forms may have been less useful. The form that I would least use in this instance is my factored form. Because I do not know the exact location of my x-intercepts, my factored form is pretty much useless. However, I could use my standard form. I'm just going to take one action and only one action. I'm going to do everything that we just did in that purple solution. I'm going to start off by subbing in the point -2, 3. And I just want you to see what you get. I am subbing this in to my red standard form. So my y-coordinate is 3 when my x is -2. Well, now I can calculate. And notice I just subbed in 1 point, and that gave me 1 equation. Now our problem is we've got 3 variables in there that we would have to solve for. We'd have to solve for A, B, and C. Some of you might be able to see where this goes. If subbing in 1 point is going to give me 1 equation, then I would have to sub in 2 more points. I want you to imagine me subbing in the vertex. Well, then you would get 5 equals 9a minus 3b plus c. And maybe you can see where this is going. You would now have a system of 3 equations with 3 variables, and you would have to solve that system to come up with all the missing values that represent that parabola. Yikes. So I hope that we can see that you could use standard form. I wouldn't recommend it. Factored form is not going to be helpful. Vertex form was the most helpful for us. So if I had to give you any guidance, the guidance I would give is, if you know the vertex, use vertex form. If you know the x-intercepts, maybe x-intercept form is best. And if nothing else seems to be helping you out, then we always know that we can go ahead and use standard form as a fallback. Okay, let's try one more on our own. Okay, I'd like you to take a look at B, and I'd like you to go start to finish. Let's build the equation of that parabola. So go ahead, pause the video now. Okay, we should be back. So I'm going to do the same thing that I did before. I can go through and label some stuff. I notice that I have my vertex here at 5, -1. But I also notice that I have my x-intercepts at 3 and 7. So I really have options as to how I want to go through and deal with this. I'm going to put up my solution 2 different ways. I always have vertex form since my vertex is shown, and so I would have expected a lot of people to start off in vertex form and then replace. What I mean by that is, let's go ahead and sub in our vertex. Now that we did that, we're still missing our A value, but if I look back up, I have been given some x-intercepts. And just keep in mind that, for instance, the x-intercept at 3 really means that we pass through the point 3, 0. And so what I can do then is I can go ahead and I can sub 3, 0 back into my parabola. Well, then that means my y value is 0 when my x value is 3. Well, then I get 0 equals 4a minus 1, and a equals 1/4. So do what the problem said, write the equation of the parabola. Let's sub back in our 1/4 with our vertex, and we're good. Hopefully that went okay, and I would guess that I would have a bunch of people that would have that same thing on their page. Okay. What if we went the other direction? So I actually think it's just as easy to say, well, if I know both my x-intercepts, then what I'm going to do is I'm going to use factored form. Because what I can do is I can sub in my one intercept of 3 and my other intercept of 7 into the factors. Recall that if I have an x-intercept at 3, then it must have come from a factor of x minus 3. Well, now that I have that, you'll notice we're kind of in the same predicament. I'm still missing that a value, that stretch factor, that shape. Well, this time I used my x-intercepts to build my equation. Now I need to use my other point. So in this case, I'm going to use my vertex to determine the shape. And so if I sub in 5, -1, then that tells me replace my y with -1 as long as I sub in a 5 for my x. Okay, I can do a pretty quick calculation. I've got a, and I'm multiplying that by 2 times -2. So that's -1 equals -4a. A equals 1/4. Hey, look, we get the same thing. And therefore, rewrite your equation. As I said at the very beginning, there were no instructions as to what form I had to use, so I can leave my form of my equation in any of those 3 forms. Watch out for the wording of your problems. They may say things like, in standard form. We would be stuck in both of these instances of expanding the brackets, collecting like terms to do so. Okay, hopefully that was a pretty quick hitter. I don't think that we need to tackle specific examples where we just give you properties. We should be able to put everything we have together and be able to go through and determine the equation in that case. Okay, best of luck with your practice.